Alright, let's start off with D. Considering changing the point of the discharge, negotiate less stringent requirements to particularly sensitive environmental areas. For example, these areas, particularly to reroute the stormwater permitted without outfall of the sanitary indirect discharge of the storm flows, are low and permitted stormwater discharge of the overly restrictive extraneous stormwater should be excluded from the sanitary systems. Stormwater pollution prevention plans should be implemented the management practice which will minimize the eliminate need for oil water separators in most instances. Formulation of oil emulsions and should be minimized. The emulsion should be resegregated with special treatment whenever the possible. Emulsions are usually complex bench or pilot plant testing generally necessary to determine effective method of emulsion breaking. Current process operating procedures should be investigated to determine the good housekeeping practices employed with the changes that can be made to reduce the wastewater and use of excess water. In many cases, the proper attention for the control of the operation greatly can reduces the amount of soluble oil requirement treatment, minimize leaking, avoiding spills, and using drip trays. Pulling spill contamination techniques to discard oil when it is no longer serviceable should be part of the oil wastewater control program. Oil wastewater systems are not to be used with spill contamination. Treatment technology. Selection of the appropriate treatment process for the oil wastewater dependent on the oil classification under the proper consent. Conditions-free oil can be removed with the gravity separation. Emulsified oil can be removed with the gravity separation. Lesser can be first be converted from free oil by breaking the emulsion. Emulsified oil may be removed from the air flotation after the emulsion may also be the first to be broken with the process of effective movable soluble dissolved oil generally requires biological treatment and absorption onto the solid phase sorbent such as an activated carbon. It should be noted that other pollutants such as solvents and phenols, dissolved metals, and other toxic hazardous pollutants are not effective for removing from the oil-water separation technology may require additional sources of control over the pre-tree treatment. Designers should understand the lack of the proper maintenance is one of the biggest that cause the oil-water separation failure. Designer must design easy maintenance so that to promote adequate periodic maintenance. For example, the buried cylindrical separators are most impossible to maintain, thus they are highly discouraged. Gravity separation. Two basic types of gravity oil-water separators are commonly used. Conventional and rectangular channels. The units commonly called API separators because they are usually based on design standards developed by the American Petroleum Institute. Parallel plates and separators. In either case, the removal of the function of the residence and time-specific gravity of the oil and oil droplet size, fluid salinity, and fluid temperature. Well-developed operated with AP gravity separators are capable of removing oil globes with a diameter greater than 150 microns, achieving the effluent level of the free oil as low as 100 milligram liters. Parallel plate separators are generally designated to remove the oil globes greater than 60 microns in diameter can make the effluent limits as low as 50 milligrams a liter of free oil. The total oil content of fluid will be greater than depending on the amount of the emulsified dissolved oil present. Other factors will also be effective the efficiency oil removal, including oil specific gravity, droplet size, or oil water separation, hydraulic retention time, and the temperature. While gravity separators are designed to remove oil, they also function as sediment oil. The dissolved solid particles, the density of the water will tend to settle out. Provisions may include, but to remove the actuated solids, knowledge of the solids content of the influent wastewater stream. In particular, the important in the selection of the parallel plate separators because of the prone increased maintenance and the clogging problem. 5511 Conventional gravity separators. A typical conventional separator system is shown in Figure 11. The separator itself of the three chambers is separated by baffles and influent chamber, the main separator chamber, and influent chamber. The operator with its chamber is described below. The influent chamber is used to remove the free oil that is already separated with the oil-water mixture during on the conveyance of the unit. Two baffles separate the influent chamber with the large main settling chamber. The upper baffle is placed at the top of the water level, extends 3/4 of the way to the bottom, and prevents the floating oil and scum from the other entering the main chamber. Allows it to be skimmed off through the overflow pipe in the lower baffle, extending from the bottom, and use the directly wastewater to the top of the main chamber to prevent short-circuiting. B. Main separator chamber. In the main separator chamber, the oil wastewater flows from one end to the upper under the consequent condition of the wastewater velocity is very low and typically less than 3 foot per minute to prevent turbulent mixing. The flat bottom chamber to remove the solids typically accomplishes the taking of the chamber out of the surface of the chamber to drain with the accumulated solid are removed either manually or by a vacuum truck. If the floor is sloped, these solids can be removed from the hopper or the V-bottom by pumping the gravity discharge while the unit is still in service. When large amounts of the solid or anticipated mechanical equipment may be provided to move the solid to the collection point, a chain drive mechanism is most common, attached between the pair of the chain with the crosspiece, but the flights extend with the full width of the tank and bay and space at several special intervals. The flights have been wooden in the past, but are now also being constructed. Alternative methods selected. Settled solids are drained in a solid hopper at one end of the tank and are removed. The oil skimming device should be provided at the end of the separation chamber. The rotatable slot pipe skimmer is most common. The other oil skimming devices include belt skimmers, floating skimmers. The waste of the oil collected by the skimmer is discharged to the waste oil level holding tank. The tank shall be designed so that the confined space entry is not required for operation maintenance. Alright, figure 11 shows the conventional gravity separator, shows the recovered tank to the oil farm, the descent tank over a decanted water feed into the baffles, tank drain, solid thickening, and disposable and adjustable slot pipe, skimmer, and treated wastewater skimming pump into the decant tank to recover the tank from farm. The fluent chamber is also separated with the main chamber by the upper and lower baffle. The water flow under the baffle and fluent with the chamber. From the fluent chamber, the treated water can be discharged with the sewer system, and additional treatment is necessary. 5512 parallel plate separator. The typical parallel plate system shown in Figure 12. The parallel plate system functions on the same principle of conventional gravity separators, but they require less space, are theoretically capable of achieving lower concentrations of fluid oil. The size of the unit is reduced, incorporating the array of the closely spaced parallel plates within the separator of the chamber. They increase the surface of the settling area flowing through the parallel plate, which unit can be 2 or 3 times the equivalency size of the conventional separator. The oil is removed from the bypassing wastewater and eliminating Lamar velocity through the pack of the closely spaced plates, which are constructed with the various inclines ranging from 40 to 60 degrees. The oil droplets rise and are trapped in the bottom of the plates. The oil droplets coalesce, gradually move upward and along with the bottom of the plates, evenly collecting the surface of the tank. The plates areas are separated within the following ways: preventing short-circuiting from the oil waste, increasing effective settling area, enhancing contact agglomeration of oil particles. Suspended solids settle to the bottom and are collected with the sludge well. For the well, the sludge is pumped, withdrawn with the gravity waste. The sludge transfers the gravity. The displacement of the automatic valve is usually provided with the plates or parallel plate separators may be made olefinic or oil attracting materials such as polypropylene, fiberglass, nylon to promote net coloncy of the oil droplets. For this reason, the units are sometimes referred to as coloncy plates separators. Coloncy separators are usually recommended only on light oil loadings, and higher level oil removal is required. The wastewater stream contains minimal solid concentration, and the facility is committed to the additional maintenance procedures required to keep the coloncy pack free of the debris. The plates may also be constructed with a corrugated configuration with the alternate troughs and the ridges, such as the so-called corrugated plate interceptor (CPI). Figure 12, parallel plate. Alright, shows the wastewater feed going into the the recovered oil goes from the decant tank to the recovered oil, and also the recovered oil wastewater goes directly into the treated water system, and then solids and thicks and disposable from the settled solid. Detent tank goes in the wastewater feed. 552, air flotation separator. An air flotation process separation of both oil and solid particles and brought about with the introducing a fine air bubble to the liquid waste that's in stream. The bubbles attach them particular matter of the oil droplets. The buoyant force of the air bubbles cause the both particles and small oil droplets to rise to the surface. The oil and solid air bubble mixture forms a froth layer at the surface, which is skimmed away. A typical air flotation system in the Figure 13, removal efficiency air flotation separated with the free oil, similar with the gravity separator. However, the air flotation unit used can also be removed. Dispersed oil droplets of 40 to 150 micron size range. Additional coagulants such as salts and iron, aluminum, and without organic polyelectrolytes may further enhance the effectiveness of the air flotation process, removing the emulsified oil. Adequate laboratory pilot studies are necessary to acquire adequate justification for additional maintenance requirements should be documented for the settling of the air flotation unit with the oil-water separation. Criteria designed for these units provided with the Environmental Protection Agency 625-179-001. Process design and sludge treatment and disposal will not be described further herein. 553. Treatment of emulsified oil. Destabilization. Treatment of oil emulsions is usually directed toward the destabilization of dispersed oil droplets causing the coalescence of the form of the free oil. The process typically contains rapid movement mixing collagen chemicals with wastewater developed with a gentle mixing of flow coagulation agglomerated oil droplets may have removed the gravity flotation. Chemical process. Alternate chemical emulsions breaking processes include either additional acids, acid cracking, iron, aluminum salts, colligation chemicals, emulsion breakers. Acid cracking of the pH is reduced to approximately 3 to 4. The wastewater must neutralize after the oil-water separation. The use of the iron, aluminum salts without polyelectrolytes may be less costly. Produce additional solids with the chemical precipitates. Proprietary chemical emulsion breakers are very effective, but they are more costly than iron and aluminum salt. Normal proprietary emulsion breakers are available through special to the chemical suppliers. Different products should be evaluated through the bench scale testing to determine which is the most effective particular application. Figure 13 shows the dissolved air flotation, wastewater going into the feed pump, chemical feed system going to the wastewater feed pump into the flotation tank. From the flotation tank into the skim float and settled solids from a floating bottom pump. The floating in the bottoms is thick and disposable. Also, while the treated wastewater goes from the flotation pump, there is also a connection from the flotation tank to the pressure retention tank of the recycle pump air. Some satisfactory manufactured oil waste separators are designed with the emulsion breaking chamber. The chemicals are added to the mixture. Otherwise, the emulsion breakers should generally be added with the wastewater with the far upstream with the oil wastewater separated with the particular for gallons for the treatment. Emulsion is given with the API publication 421. Mechanical impingement and filtration process. Other methods of resolving emulsified oil include mechanical impingement devices. Filtration represented with the former are so-called coagulancy filters. Cartridge type emulsion breakers are then used. The final step of the FRAM oil water separation system. Following solid set filtration sediments and free oil removed with the FRAM type of the cartridge, which contains metal decontaminating numerous small 25 microns of regulated continuous patches through the wastewater flow. If the emulsion is broken and impingement with the oil drops with the surface of the medium of the cartridge, backwash with the oil replaced. The coagulancy type of the separator is recommended only with light oil loadings. When higher level the oil level removed required, the wastewater stream contains minimal solids concentration. Facilities committed with the additional maintenance procedures required to keep the unit free of the debris. Pressure filters may also be used to remove the dilute the concentration mechanical emulsified oil, usually as a polishing system of the downstream gravity flotation units. Bentonite clay with the anthrace are typically used for the media. Application filters, military installation is suspected with extreme rare, but the design of these units is not covered herein. 554. Treatment of dissolved oil. Treatment of dissolved oil is not normally practiced in military bases. Dissolved oil that may be present with expected to be removed by the biological treatment process employed by the FOT and POTW, which wastewater is discharged. The pre-treatment with should be probable method of choice. There are other treatment technologies, membrane filterization, advanced oxidation techniques. These technologies are rarely cost-effective compared to the absorption of biological treatment. Design oil-water separators. Designing the conventional and parallel plates of the oil-water separator system requires proper characterization of the wastewater, establishing the design's low sizes that penetrate, signs and proper flow of the attuation and flow equalization of the influent. The designer should work and identify the user's need for the capability of vendor-supplied equipment. These aspects system design discussed following the paragraphs. 561. Wastewater characterization. If it's possible, the wastewater treated by it should be analyzed with the total oil of grease using conventional method given by the EPA standard method. The American Society testing materials in addition free emulsified dissolved oil fractions should be determined with the method described by the AIP publication 421 referred to in paragraph 523. In absence for the data design, global diameter of 150 microns can be assumed for the design of the conventional separator, 60 microns for the parallel plate separators. As indicated previously, although the oil waste separators are designed to remove the free oil, they also remove the solids. Therefore, the solids contaminated the wastewater The overall system design analyst should be typical of the TSS, vital suspendable solids VSS, and settable solids. The analysis will be help determine the amount of the frequency from the settled materials that will be needed to remove from the bottom of the oil waste separator. The visibility for the providing grit removal upstream of the oil waste separator. Other wastewater characteristics important for the design of a wastewater separator with the specific gravity of water phases. The absolute viscosity of the wastewater, both at the minimum design temperature of the wastewater temperature, majors the impact with efficiency with the separator. With the pore separation occurring with a lower temperature, separators are not designed to remove the pollutants from the ethanol, solvents, or heavy materials. These pollutants should be addressed by the use of pollutant prevention techniques. Site consideration: oil wastewater sediment separators should be designed to the readily accessible for the maintenance inspection, visible inspection, ability to probe the solid levels are critical to good operation. Above ground units, the easiest way to access maintenance inspection, and below ground units should have the adequate access points of inspection. Cleaning the background units should also be installed with a liner and leak detection system. 563. In establishing design flow, sufficiency of separation decrease if the flow exceeds the design capacity of the separator. Therefore, the design flow should be based on the maximum flow rate to be treated with, including the additional any of the future oil, wastewater, stormwater runoff, and determining the peak flow rate. The variation between the shift and the daily, any seasonal variations could be considered. Flow rate should be measured with the wastewater generation process already exists, accurately estimated where it does not. In some cases, establishing production-based wastewater generation rates must be useful for projection future fuel flows. For example, the maximum flow expected with the aircraft washing facility may be established from expected wash water per aircraft multiplied by the maximum number of the aircraft to be washed by the given period. If the unit wastewater generates rates in another facility area, the different conditions should be accounted for, such as difference in the type and the size of the aircraft washing procedure. With high flows of the short duration are to be handled with the alternative construction large separator to divert extraneous flows from the system. For example, an outdoors wash rack would be curved and provided with a manual control valve to allow the storm runoff to be diverted to the separate drain from the rainfall periods. In general flow equalization upstream with the oil wastewater separator, and the beneficial where the oil wastewater would be otherwise experience slug loads. 564. Design criteria for the conventional separator with the following parameters should be considered with the design of the conventional oil wastewater separator. Design flow: the minimum wastewater temperature, the wastewater specific gravity, the wastewater absolute dynamic viscosity, wastewater oil fraction specific gravity. F. The minimum global size to be reduced, usually 150 microns. The type of the amount of the detergents present in the wastewater, potential change in the future detergent use. The quantity of the solids to be removed to handle the fluent pre-treatment limits to be meet. The design criteria should be conformed with the criteria established with the API as follows. Horizontal velocity through the separator should be less than equal to 3 feet per minute, equal to 15 times the rise rate of the oil glue. Separate water depth should not be less than 3 feet. The ratio separator depth of the separator width should be typically in range of 3/10 to 5/10. Minimum length of the width is 5 is recommended. Where continuous service is required, back up the channel of the unit. It shall be provided with a step-by-step design procedures. Refer to the API publication 421, Military Handbook 1005. 9. Also contain the design information. Design criteria for parallel plate separators. Parallel oil waste separators are furnished with a pre-engineered factory assembled unit that's designed with a varied manufacturer and vendoring experience. It must also be used with the unit sizing selection. General, however, the parameters and procedures used with the design parallel plate separators are the same as for the conventional separators, except for the small design global diameter of 60 microns is usually assumed. The perpendicular distance between the plates typically range from 75 to 1.75 to 1/2 inches, and the angle plate, the inclination from the horizontal typical range with between 40 to 60 degrees. Placement of the oil waste separator to provide accessibility, particularly important with the parallel plate separators. Accessibility is essential, maintaining the parallel plates in the separation chamber, which may require future frequent cleaning of the removal of the cleaning with a high pressure cleaning equipment. Is procedure for the choice. This cleaning, if the cleaning is in place, is used. The hose connection proper provisions and minimize the work health and safety risk should be provided. A high solids concentration are present and may be advisable to install the sediment basin upstream of the oil wastewater separator. 5.7. Oil sludge removal disposal. Sludge and oil that are not periodically pumped with the separator holding tanks can be rendered by the oil waste separator inoperative. Reliable oil removal from the surface of the separation chamber is a frequent problem to both commercial available units and customer design separators. Currently, the most satisfactory method involved the suction removal they installed with the personal using equipment normally used for the cleaning catching basins. This equipment is commonly referred to as known as the vacuum or vac all trucks. Oil and oil sludge is removed. The oil waste sediment might be disposed of the use of reuse, recovery, incineration, sale by the Defensive Reutilization Market Office. Waster, hauler, landfill, land disposal are recommended. The final disposal options evaluated concurrently with the oil waste separation methods, environmental requirements to establish the most effective total system. The sludge may require the regulation of the hazardous waste if the level of the pollutant exceeds the RCRA and state hazardous waste level. The further leaking of the oil waste separator contains the hazardous waste can result. The designation is a solid waste management unit and subject to the corrective association with under the RCRA regulation Title 40 CFR subpart F. Guidance documents. These following documents provide additional guidance for the design selection of oil wastewater systems separators. All refer to the reference section of this handbook. ETL 1110-3, the selection and design of the oil wastewater separator of the Army facility. Army Engineering Technical Letter, August 26, 1994. The ETL is comprehensive design guidance document for the oil wastewater system separator. Military Handbook 1005-9, Industrial Oil Waste Control API Publication 421, Design Operating Oil Wastewater, American Petroleum Institute, 1220 L Street, Northwest Washington, D.C., 22005, February 1990. The headquarters of the USAF CE Memorandum of Oil Waste Separator Operation Maintenance Construction, October 21st, 1994. This memo includes the environmental compliance, but we'll see the oil waste sediment separator operation maintenance construction. Headquarters of the Air Force CEE Protect Act of the Pro Act Fact Sheet Oil Wastewater Separators, December 1996. Web address afces.brooks.afl.mil. Pro Act Main Pro Act 4 HTML. Section 6, Package Plants and Small Flow Treatment Systems.